I am not sure whether you need to register this consultation, but no harm lah. Tomorrow morning, you try. For those students who are already on the LSP program, you will definitely be invited to join. A reminder to join the consultation tomorrow morning. For those who are not invited, you can try your luck tomorrow lah. Okay, just go in this, click, use the search button END and then search for this NSAM test consultation. Okay, then see if you can join tomorrow. Okay, class. Any questions about so far about all these things I've shared? Anything you wish to clarify further?
No, sir.
Okay, can. So let's go through the paper. Okay, let's go through the paper that you just did, right? Where is the paper? Okay, and now you can see. Okay, you can see, right? Oops. Okay, now first question is on the frequency response curve of a BJT CE amplifier. Okay, determine the pass band gain. What is the pass band gain, class? What is the pass band gain? What is the value? What is the value? Class, what is the value? What is the pass band gain? Hey, hello. What is the pass band gain?
13.
Yeah, 13. Hope you all got that right. So basically, the pass band gain is where the gain is flat top, flat. This, oh, I see my, it's in black color. Draw in red color. Okay, red color. No. Use a different color. Maybe green. Green. You know this green. Okay, so there's a pass band gain. So it is 13. So I hope all of you got it right. 13 decibel. So what is the absolute value there? If your pass band gain is 13 decibel, what is your absolute gain? What is the absolute value?
So 4.47.
Yes, correct. Correcto. 4.47. Okay. Answer is 4.47. So your pass band gain is 13 dB and your absolute value you inverse log basically you take the reverse log, inverse log, 10 to the power of 13 divided by 20, then you get the answer of 4.47. Okay, yeah. Now B, let's look at B. The voltage gain in dB at the cutoff frequency. Okay, what is the voltage gain at the cutoff frequency? What is the voltage gain? What is the voltage gain? Jeannie? What is the voltage gain? Jeannie? Jeannie? Hello? What is the voltage gain? Hello? Didn't go toilet, is it?
Is it 10?
Say, confirm. Is it 10? Tell me. Very confident one. It has to be 10. Remember, your pass band gain is 13, right? So to determine the cutoff frequency, it is always 3 dB down. So your 3 dB down, right? So answer is 10. 13 minus 3, always 3 dB down. So from the cutoff frequency, from the voltage gain and the cutoff frequency, you can determine your FL and your what you call it, FL and your FH. So this is your This is your FL. So what's the FL? 2K. What is the FH based on this graph? Drop down 90K. Okay. Okay. I hope you can see my ugly handwriting. FL is 2K. If you read from the graph, and your FH is 90 kilohertz. So what is the bandwidth? Bandwidth, the working is FH minus FL. So answer is 88 kilohertz. 90 minus 2. So it's 88 kilohertz. I hope everybody got that right. Jeannie, you got that right also?
Yeah, got it.
Okay. So first question covered already. The rest of you, any thing you would like to clarify further on this Q1, question 1, frequency response curve? Now, no, not finished yet. Now you are given part C, right? Part C, you are given an input signal of 100 millivolt peak to peak at 5 kilohertz, right? At 5 kilohertz. What is the output voltage? What is the value of the output voltage? Okay, so let me just erase it so you all can see. Okay, now what is the, if you inject a input signal 100 millivolt peak 5 kilohertz sine wave, right, into this amplifier, what do you think is the output voltage? Okay, now first you must determine 5 kilohertz. At 5 kilohertz, what is the voltage? You know, at 5 kilohertz, what is the voltage gain? Where is your 5 kilohertz? 1, 2, 3, 4, 5. So 5 kilohertz is 5 kilohertz is 5 kilohertz is 13 dB, right? Your gain is 13 dB, correct or not? At 5 kilohertz, 5 kilohertz, if you look at the thing, your gain is 13 dB, right? 13 dB. Okay. So what is the absolute gain? At 13 dB, if you do an inverse log, it is 4.47, right? So what is your output voltage? It's simply 4.47 multiplied by 100 millivolt, which is 447 millivolt peak. Understand? This part you need me to explain further, class? Is it okay? Is it okay? You all
Sir,
understand?
can be again, sir? How you get 447?
Okay, I see. Now, let me draw again. Let me just erase again. Okay, look at C. Look at C. Look at C. Now, you inject a signal into the amplifier. It is 100 millivolt peak. And the frequency of this input signal is 5 kilohertz. So 5 kilohertz sine wave. So the voltage gain of this amplifier is like that lah. This is the voltage gain of this amplifier. Then you go and count 5 kilohertz. Where is 5 kilohertz? 1, 2, 3, no, 2, 3, 4, 5. So this is your 5 kilohertz, right? 5 kilohertz. So we extend upwards. Okay, extend upwards, and it hits the pass band actually. It hits 13 dB. So your voltage gain at 5 kilohertz is 13 dB. You understand? It's 13 dB. Do you understand this point, BJ?
Yes.
So at 13 dB, what is the absolute? Again, you take inverse log of 13 dB lah. You get 4.47. Oh, so your voltage gain at 5 kilohertz is 4.47 times. That means if we inject 100 millivolt peak, what will be your output voltage? What is the magnitude? It will be the voltage gain of 4.47 multiplied by 100 millivolt, which give you an answer of
447.
yeah.
Oh, okay. Thank you, sir.
Okay, understand? What about the rest?
Yes.
Can can understand So if I were to give you okay, let's say I do something else I do, let's say, you know, should I confuse you further? No, I hope not. So let's say I ask you to inject in 100 millivolt. What will you like? What kind of frequency will you like? Okay, let's say I inject 100 kilohertz signal. Okay, I say okay imagine class imagine I inject 100 kilohertz signal I inject 100 kilohertz signal. Okay, let's say I inject 100 kilohertz signal. What will be your voltage gain in this case? What will be your voltage gain? What will be your voltage gain?
9. Is it 9?
Yeah. Yes, correct. So you see, what happened? Okay. So, what happened? My it hang for a bit. Okay, all right, can. Okay, you see at 100 kilos you extend upwards, then you hit actually is 9 dB, right, BJ? Then 9 dB you do a inverse log to get absolute gain will be 10 9 divided by 20. What is the answer? Can you calculate this for me? What is the answer? At 9 dB, what is the absolute gain?
2.8. 2.
2.82 lah. Let's say 2.82. So your how come I confuse people? 2.82 So your voltage gain is only 2.82. Therefore, your output voltage will be, what is the output voltage? Magnitude.
2.82 times 100, right?
Yeah, so 2.82 times 100, so you get 282 millivolt. The frequency does not change. It's not changed by the amplifier. It's still 100 kilohertz signal. So is that clear about how to solve this kind of problem?
Yes.
Okay, can. Good. Right. Okay. All right. So I won't confuse you further. So, okay. Let's move on. Let's see. Juliana, are you there, Juliana? Juliana, are you there? How come everybody go toilet one? What about Noriham? Okay, I move on. Okay, I move on. Okay. Otherwise, no time to cover already. Okay, let's go on to the next question. Okay, this is a JFAT question. So you have this second question is about JFAT, and the good thing about this question is that the graph, you don't have to plot the graph. You don't have to plot the transconductance curve already. It's already plotted for you. So you only need to determine the intersection point this one. So in this case, your VGSQ, right? You see the intersection point. Your VGSQ is -2, right? Okay, why it jump to here? Okay, so basically, your VGSQ is minus 2. Can you see? It's minus 2. Minus 2. So minus 2. And the IDQ is 1.5, right? Okay, so already you get two answers already. So I'm talking about here, this part here. So your IDQ is from the curve, it is 1.5, right? Milliamps. And your VGSQ is minus 2 volt, right? You can read straight from the graph. What about IG and VG leh? Okay, IG and VG. You know very well, class, that IG, because the input impedance of the gate of the JFET is very, very high, close to infinity. So your gate current basically is 0, close to 0. IG is close to 0. So that's your answer. Okay. Then VG leh, because your IG is 0, and you notice that this is the ground is attached here. It means that your VG with respect to ground is also what? If your IG is 0, what is your VG with respect to ground? What is the voltage at VG? If the current moving in is 0 and is attached to ground, like that. What is the voltage of VG, class? What is the voltage of VG? Class, what is the voltage of VG?
Is it 0?
Yes, 0 because current is 0 so no current flow through. So no current flow through, you can see that the VG is actually also grounded. It's also at ground level. Okay. If you need, you take that down. From the graph, you can read that your IDQ is 1.5, and your VGSQ is minus 2 volt. From the graph, from here, right? From here and from here, you can read off at the intersection between the curve as well as the load line, right? So that's what you have. Now, then what about VDSQ? How to do VDSQ? How to do VDSQ?
Is V 5 volt minus 1.5 MA, then the resistor.
Yeah, so basically, you take the KVL down. So basically, your VDSQ is VDD minus IDRD minus ISRS, right? Is that what you're saying?
Yes.
Correct, right? So basically, your VDSQ will be equals to KVL down. Down will be VDSQ will be this part here. So it will be VDSQ will be VDD minus IDRD minus ISRS. But you know, in a JFET, right, your ID and IS are the same. So you just replace by the common current. So you use ID. Also, you have your VDSQ will be VDD minus IDRD minus IDRS. Okay, right. So if you substitute everything in, your answer will be, oh, I hope you get it. All of you get it, right? Okay. So the VDSQ is 4 volt. Then your small signal model for this one, you draw the small signal model, right? Draw the small signal AC equivalent model for this is a common source CS amplifier, CS JFET. So pardon my ugly see when you draw on this just doesn't look nice. Yeah. So there is your small signal model. So remember, must include the Z. The Z out is inside. Z out is inside. Okay. Z out is inside. And then you have the VGS, Q, and then the ground is there. Okay. VDS, the small signal model you can copy from your lecture notes or your tutorial. It's a standard, very standard one. The only difference, the only thing you need to take note, right, is the RL. So you look at your original circuit. You look at original circuit. Right? You look at original circuit, whether got RL. If there's RL there, right, then make sure if there's RL there, make sure your you have RL also in the small signal model. Okay. So far, so good. Okay. I can't become a 2-page.
So wait, let me take picture.
My ugly handwriting still take picture. I hope you can interpret. Yeah.
Thank you, Chair.
Okay, can. The rest of you, any questions? Melvin, are you there? Melvin, any questions from you? Melvin, are you there? Nikki Melvin Singh. Actually, I don't know why this is the most important time, right? Where I'm reviewing the answers with you all. Ai. Nicholas, are you there? Nicholas, okay? Any questions to ask?
No, Cham.
Okay, understand.
I'm good. Yes, I'm good.
Okay, then let's move on. Okay, next question. Okay, this one. This is your BJT already. Okay, BJT. Okay, this is your BJT. Okay. Now, third question. This is about BJT. Okay, so basically, what is this called? What is the bias? This is voltage divider bias. This is a BJT. Right? This is a BJT. BJT. Okay. Now, so you're given all the H parameter value, HJE, HFE, and you're given that the other two parameters are negligible and that you have you're given this, that your beta DCRE is greater than 10 R2. Okay, and your CE during small AC signal, right, effectively bypasses RE. Okay, these are very important for you to simplify the entire circuit. So you are supposed to calculate DC biasing, calculate the VB, VE, and VCQ. So your VB, okay, because of this value here, your VB will be what? Your VB is simply the voltage divider circuit, right? The VB you can calculate using the voltage divider rule. Okay. Okay. Your VB is simply the voltage divider rule because you have the beta DC times the RE is much bigger than the 10, what you call that? Sorry, just your beta DC times the RE is much bigger than the 10 times of R2. So that's why you can simplify the calculation of VB. R2 divided by R1 plus R2 times VCC. VCC. VCC, this is VCC, not VCE. VCC, this one is VCC. Okay? VCC, right? 12 volt. Then once you calculate your VB, right? 2.4 is 2.4 volt. Your VE will be VB minus VBE, which is 2.4 minus 0.7. The forward bias voltage of a diode is 0.7. So it's 1.7 volt. And with your VE calculated, you can calculate your ICQ. Here your ICQ is simply equals to your IE. Because data is very huge. So you can calculate your ICQ to be 0.85 milliamps. 0.85. Let me write nicely for you. Okay, 0.85 milliamps. All right, so based on that, your VCEQ you can also similarly calculate to be 5.2 volts. Okay, by taking KVL here. Okay, this one. By taking KVL down this loop here. All right, KVL down this loop. Right, KVL. So your VCEQ will be equals to VCC minus ICRC minus IERE. Okay, so that's why you have this. But you remember your IE and your IC are almost the same, equal to each other because your beta is very huge. So substituting the value, VCEQ is equals to VCC minus ICQ ICQ bracket RE plus RC. So your answer is 5.2 volts. Okay. Then if you're asked to draw the small signal model, this is what you will see. This is your small signal model. Okay. Yeah. This one you can quite standard one. You can obtain from your lecture notes or tutorials. In this case, your input, the input side, right? Okay. When you do the small signal, you kill the VCC, right? You see, you kill this one here. So this one you connect to ground, right? So once you connect this one to ground, okay. Once you connect this point to ground in doing small signal analysis, then your R1 and R2 becomes parallel. Okay, so that's why you have this here thing here. All right. Now, then what about your gain? What about your gain? Your voltage gain is the standard one. You just see your tutorial and lecture notes. It will be HFE multiplied by your IB multiplied by RC. You know this one here, HFE IB multiplied by RC divided by IB times HIE. Okay, which is your VGS. Your VGS. So your answer is minus 320. Okay, and your Z out. Okay, based on this by observation, your Z out is simply RC, which is 6 kilo ohms. Okay, do you all know how I derive the gain as well as the Z out class? Anything you wish to clarify further? Do you all get answer minus 320? Remember for BJT, for a CE configuration, common emitter, right? your voltage gain is a minus, is a minus. What does a minus mean, class? When you have a minus, what is the relationship between the input voltage and output voltage? Class, if I have a C always minus, right? Negative 320, negative. So what does this tell you about the relationship, right? The phase, the phase relationship between input and output. Kishan? Any guess? Kishan? Oh, cannot see. What is the relationship? Oh dear, your mic spoiled. Yes, 180 degrees out of phase. Okay. So whenever you see a minus at the voltage gain, right? The output voltage and input voltage is 180 degrees out of phase. Okay. Now, if I ask you to draw the input and output voltage waveform, you know how to draw? Huh? You know how to draw or not? You should know how to draw. All right. If I ask you, because your gain is negative, so that means your input and output voltage is 180 degrees out of phase. Phase difference is 180 degrees. So with this information, if I ask you to draw the input voltage waveform and the output voltage waveform, you should be able to know how to draw. Okay. Anything else about this question, class? Anything which you wish to clarify about question 3 on BJT? Can get it? Class, anything you wish to clarify? Question 3? Dennis, are you there? Dennis? Dennis?
Yeah.
Understand about question 3? Anything you wish to clarify?
No, it's okay.
Okay lah, can Okay. Then let's move on. Okay. The last question, quite simple. Okay. So, when you look at this configuration, what is it? When you look at this configuration, what is it? The input signal is input through the non-inverting, and you have the feedback. The feedback loop, feedback network is connected to the inverting. So what is this? What is this configuration called? So simply is a closed loop non-inverting op-amp. So with that, right, you immediately know what is the voltage gain, right? Voltage gain is 1 plus R3 plus R2, right? Yes. How come all disappear? Okay, so immediately your gain from here, the AV, right, is equals to 1 plus 1 plus R3 over R2. This is the non-inverting gain. Okay. All right. So this is the answer lah. Now your okay. So basically, if you look at this one, right, what is the non-inverting voltage and the inverting voltage? Okay, what is the value? All right, V minus, because there's no current flowing into the what you call that, the inverting input, right? So your V plus Oh, no current flowing in. So your V plus is simply 2 volt also. And your V minus, because of the very high gain, very high gain between V plus and V minus, your V plus, your V minus is simply equal to the V plus. So it's also minus 2 volt DC. And your V out is simply apply the formula 1 plus R3 R2 times V in. R3 is 20K, your R2 is 20K. So you'll be 20 divided by 20 is 1. So you have it as 2 times 2. So answer is 4 volts. So your V out is 4 volts. This one is non-inverting. Right, properly. Very hard to write properly. Okay. Any questions about this last question?
No, sir.
Quite straightforward lah. In this case, quite straightforward now. Your V plus equals to V minus, right? 2 volt, and your V out will be the gain, the voltage gain multiplied by the 2 volt. Any questions to clarify further? Any other further questions you wish to me to clarify?
No, sir.
Okay lah. The rest of the class, The rest of the class?
Yes, we are good.
Good lah, all good lah. All good, all good. Jeannie, anything for me?
No, no question.
Okay, no question, okay, so next week 100 marks already, okay. Okay, right. So I wish you all the best for your exam next week. Don't forget, it's a Tuesday paper, morning paper. All right. So it's a face-to-face. It is not home base. Face-to-face, you have to come to TP. I hope you know where's your venue. I think you already know the timing and the venue already, right? Okay. So without further ado, then I wish you all the best for your exams. That's it lah. Bye.
Thank you, sir. Bye
Okay,
bye.
bye bye. Bye bye.
Thank you.
Bye bye.
Bye bye.
Teacher,
Bye bye.
Bye.
We will